So I'm sure you've encountered this as well. So yesterday when I left class, it's still bugging me that when I looked at these problems the first time, that I'm not sure what program on the calculator to use and get what they're looking for, which is the error. There are manual ways to do it, but I don't want to teach you that. I don't want you to have to be burdened with all that. And when I saw this, it didn't click in my head what the hell to do. So driving from after class, for this semester anyway, I finished up your class. I jumped in the car and I drove over to New Haven, and then I teach 2 classes there. So I am driving over, and I'm like, okay, I'm stupid because this is pretty straightforward. So they give you all this information. They tell you what n is. They tell you what the mean is. They tell you what standard deviation is, and they want us to know, they want us to determine what the margin of error is. And if you recall yesterday in class, I reiterated the idea that our margin of error, again, if you watch the news or whatnot, and they're talking about some study or some, maybe it's only on the podcast I listen to because the world generally is statistically, I shouldn't say illiterate. That's not exactly true. I think it's more accurate to say that that in general for people, statistics is not a natural, intuitive thing. It doesn't just make sense straight away. In some things it is, but in other things, not so much. And so you have to think about it and sort it out, I believe. And they sometimes call, they use their own terms, and they call these things error bars in some settings. Some journalists do. But if I'm looking for a 95% confidence interval, let's say that for whatever I'm working with, this is the 95%. Let's not use those. Let's use the shading. So this area under the curve is our 95% that we're looking for. Okay? Because the 95% corresponds to that area under the curve. So this represents the 95%. Now the error bar, or the error, the margin of error, is this mu, or the mean, plus or minus this amount. That's our error bar. So really what we're trying to find is this mu plus or minus. This is the minus the error, and this is the plus the error. And I mentioned that yesterday. And we've talked, you may have surmised that it's not like it's a complicated idea, right? But how do we sort it out? So this problem is really asking you need to find the confidence interval first, because if I find the confidence interval, that's really the teasing out or the representation of these 2 numbers that gives us that range, right? We've seen it written like this as an interval, in interval notation. We've also seen it like this, where this is minus the error. It's actually not minus the error. I guess this is written incorrectly as well. This is really mu minus the error, so that it's this number that's right here, and this is mu plus the error, so it's actually that number there. This is also mu minus the error, and this is mu plus the error. And mu is going to be halfway in between. So it's right in the middle here, halfway between those numbers. So if we have those ideas in our head, we simply, and I don't know why I didn't get there with the calculator thing, but we simply go to calc, tests, and t-interval, which is 8. And we can do that because they've given us all the information. So I just did this problem to confirm. Actually, I didn't confirm all the way. So if we go look at the results of this, because I didn't check the answer, so maybe this will blow up and I'll have to re-record it. We get a confidence interval for that scenario and those numbers as 38.671 to 49.329. So conceptually, remember, this 38.671, that's this number here, 38. let's say 38.7 because of the space up here, or the lack of space. And so what's our estimated mean? Well, we were told that's 44. This 44 will be halfway in between this 38.7, 49.3. So how do we figure out what the error is? Well, the error is this distance. So all we need to do is either take the mean and subtract it from this, or we take the mean or take the lower bound number and subtract it from the mean. Those are two ways because that's the distance. Or you can take and this is where this detailed solution thing that I was like, what? Why are they providing you with that information? Well, it's because of this. You can also take the upper limit, subtract the lower limit. Of course, that represents this whole distance, right? The distance across the interval. And if I divide that by 2, that's equal to this distance here, the error. Okay? So that's why they had that information there, but I'm like, yeah, we know that, but how does it help with this problem? Because I couldn't figure out that the path was to figure out what the interval is. So maybe some of you have already sorted that out, and sorry I was so thick-headed. For this particular problem, it would be 49. I guess we want to clear this. 49.329, because I think they want two decimal places, so we're going to have to include all 3 of those. Subtract the 38,671. And hit enter. And we're going to divide. That's the distance across the whole span from the upper limit to the lower limit. That's our confidence interval. But we want the error, so that's the plus or minus, or meaning that's half of that amount. And we get 5.329, and there we go. Okay, so I'll do it a second time because we have another problem here that uses this idea in this question set. I think it's that one. Yeah. So there's our question. There's the calculator. And so again, we go to stat, slide over to tests, slide down to t interval, or just click on 8. And remember, it's the t interval because we don't have the population mean. We only have the sample mean. And so this is why it's a sample. This is why it's a confidence interval on the sample mean. And we're going to use statistics because that's what's provided to us. We weren't given a data set. We did enough problems, I think, yesterday with the data sets that you can see that you can get there a number of different ways. So we're going to type in 49 as our mean. Our standard deviation in this particular case is 5. The margin of error, n is equal to 32. And the confidence level is 0.95. They didn't change it for this particular version of the problem. And so we get a confidence interval of 47.197 up to 50.803. Oops. Man, that is poorly written. But you get the gist, and I'm talking at the same time. So remember, that's the span across the whole confidence interval. Our mean being right in the middle. I guess this is mean minus the error, and this is the mean plus the error. And so this distance between those two numbers is this distance, and I want to know what half of that is. So I can take 50.803 and subtract 47.197, divide it by 2 to calculate what the error is. And so we get 50.803 minus 47.197. Hit enter, divide that by 2, and we get the error, which is 1.803. Okay, so hopefully this helps. Again, sorry about yesterday. And again, send me any questions as you have them. I'm here. I'm not going anywhere. I'm here all weekend. All right, take care. Bye.